Looking at problem 10, we're taking a look at a sequence, arithmetic sequence, which means that the same number is being added each time. And we know that the third term is 13, 17th term is negative 29. We want to figure out what is the eighth. So, looking back at Uncle Zachary's method from problem 2, he wrote down t of n equals 50 plus 3 times n minus 1. Now, 50 was our first term. 3 was the amount it's changing by, which is the same as slope because arithmetic sequence is like a linear equation. The n is our term number, and that was the value of the term, t of n. So if I take a look at this first piece of information and just use that equation, the third term is 13. So that means 13 equals, not sure what the first term is, I'm just going to put a variable in there. I also don't know how much it's changing by, so I'll just use another variable. But I know that it's the third term, so I have that information. Using then this piece of information as well, negative 29 is the 17th term, and I still have the same change and the same starting value. This is now a system of equations that I can go through and solve. So I'm going to simplify the parentheses. So I then get 13 equals x plus 2y, and simplify the parentheses here, and I get negative 29 equals x plus 16y. I'm going to solve this by elimination. Multiply the bottom one here by a negative 1. That's going to give me positive 29 equals negative x plus 16y, minus 16y, sorry. And now I'm going to take that and add it to this equation here. Now when I add them, my x's will eliminate. I will get 42 equals negative 14y. Y will equal negative 3. So the change here is negative 3, which makes sense because it's going from 13 down to negative 29, so it is going down. Your change has to be a negative value. Now once I have that, I'm going to put that back into one of my equations. I'm going to use this blue one right here. So I have 13 equals my starting value, or my first term rather, plus 2 times negative 3. So I get 13 equals x minus 6, and x will equal 19. So I now know that my starting value, or the first term here, is 19, and I know my change is negative 3. Using that information, I can now figure out the eighth term. So the eighth term then is going to be 19 plus 3 times 8 minus 1. So that's going to be 19 plus 3 times 7. Oh, I'm sorry, this should be minus 3, because it's a negative 3. So that should be 19 minus 21, which will be a negative 2. So the eighth term, t of 8, equals negative 2. There is another way we could figure this one out if you didn't like that method. If I think of this now written as a sequence, I have the third term here as 13, and then I get a bunch of other terms here, and then it's negative 29 here at the 17th term. This is the third. So from third term to 17th term, that is going to be a change of 14 terms. From 13 to negative 29 is going down 42. So if it's changed by negative 42 in 14 different terms, I would take negative 42 divided by 14, and that's how I'm going to get my negative 3. So if it's subtracting 3 as we go through, that's 10. Then I would have 7 and 4 and 1 and negative 2. So if that's my third, fourth, fifth, sixth, seventh, eighth term. If I want to get the equation, I could just work backwards as well and add, and I get 16 and 19. There's my first term. And I could write the equation T of n equals 19 minus 3 and minus 1. Hope that helps.